All right, MCT4C, day 13, part 2. We're back. Some examples now from what we've learned. State the amplitude and period of this function. State the domain and range. So um, the amplitude, remember, comes from the first number. Now, we always think of the amplitude as a positive number because, amplitude is the height of a bump. And we know even if it starts going down first, that amplitude is still, whatever that number is, but positive. So we know the amplitude, well, A is negative 3.6, but the amplitude is 3.6 because that distance is 3.6 units. Now, for the period, remember the period is 360 divided by B, where B is whatever number's in with the x. So this is 360 divided by 1/7. And we know since this is a fraction, it's actually a horizontal stretch. Big number, actually, because when I divide fractions, remember, I invert and multiply. And that is 360 times 7, which is 2520. And I'm really glad that I don't have to graph that. I wasn't asked to graph it. The domain, well, the domain, even if a sine function has been stretched vertically, stretched horizontally, it still, goes on in both directions forever. So the domain is still x is a member of the reals. I can put any number into my calculator and that's going to work. But the range, well, the normal range was -1 to 1. Right? That's normal, but that's not what it is here because the amplitude is 3.6. So each of these numbers have been stretched vertically by a factor of 3.6. So it goes down to -3.6 and up to +3.6. There's the range. Well, example 1 and then example 1 again. I never noticed that until this very moment. Oh well. I'm sure you can handle it. For each function, state the amplitude and the period, then graph. Okay, this is what we're really after today, is the ability to graph some of these functions once we're given the equation and something's happened. So here, the A value is -2, so that means the amplitude is 2, but what does the negative mean? It means we've got to flip as well. Okay, and then the period, well, there's no number in with the x. The period's actually just 360. I could think of the b value as 1, but it's just 360. And so this is normal for period, right? And so how are we going to do this? Well, do I have to graph the original one? Well, I could, but I think more and more you're not going to because you're so good at graphing the original one. So here's the original, just for funsies. I'll put this real quick. Sine graph. That's the original. And again, as you become more comfortable, you're not going to need to graph that. You probably, most of us, can go right to the final one. Remember, the amplitude is 2, so it means the highs and lows are 2 units from the x-axis, not just 1. And notice the minus means I'm going in the different direction. No translations left or right, so I got the same starting spot, and no period change, so my important points are still every 3 ticks, every 90 degrees. Important point every 3 ticks, important point every 3 ticks, important point every 3 ticks. Lovely. And then that function there is y equals -2 sine x. Is there a b down here? Somewhere there's a b, isn't there? Yes. And a c even. Here we are. So this one, we see the amplitude is 1, right? Amplitude's 1. But the period, and this is one of the ones we graphed, is 360 divided by 3 is 120. So remember, what the period means is that I got to repeat my cosine graph. And I'm going to make that 1 here to -1 just because there's no amplitude change. I'm going to use my regular scale, it's got to start repeating by 120. Or I could think of having to fit 3 cosine graphs in by the time I get to 360, right? That's pretty hard to be able to do that. Well, how we actually graph this is by thinking of the important points. Important points in the regular one was every 3 ticks, but now the important points are every 90 degrees divided by b. Every 30 degrees is every tick. So again, I'm gonna just for comparison's sakes, again, normally I don't think you'd do this. Here's the original sine graph, or cos graph rather, and the important points are every 3 ticks, every 90 degrees. It's not very nice, but it'll do. And so my squished graph, my period, it hasn't been moved left or right, so this starting spot's the same, but the important points aren't every 3 ticks, they're every tick. They're not every 90 degrees, they're every 30 degrees. Important point every tick, important point every tick, important point every tick. And then I can just follow the pattern, high, middle, high, middle, low, and notice that it actually starts repeating at 120, 30, 60, 90, 120, and it's all good. Important point every tick, important point every tick, important point every tick, important point every tick, important point every tick. And it actually works out, doesn't it? And notice I kept going for the whole 360. It wanted me to graph the whole 360. Try and not make teeth. It's really hard not to make teeth with the graphs, so frequent like this, but there's 1, there's 2, there's 3 by 360, and it all worked out great. This one's got 2 things in it, right? We know the amplitude is 2, no flip. The period now is 360 divided by whatever number this is, divided by a half. That's 720. So that means it's going to start repeating. You put that in your calculator or invert and multiply, you get 720. It's going to start repeating itself every 720. It's this one that's a horizontal stretch, right? And of course, we think of graphing this by the important points. 90 divided by a half is the same as 90 times a half, or 90 times 2 over 1, flip and multiply. Every 180 degrees, I'm going to get an important point. Well, that's kind of weird, but we'll do it. Remember, normally, the normal cosine graph, important points every 3 ticks, which is every 90 degrees. But this one, and I'm going to start with an amplitude of 2. Cosine starts up on the y-axis. And then the important points aren't every 3 ticks. The important points are every 6 ticks, every 180. In fact, I can only get a half a graph in by the time I get to 360. And that makes total sense because that's what the b value is, right? Lovely. All right, what do we got left? Nothing down there. A cosine graph has been compressed vertically by a factor of 0.25 and compressed horizontally by a factor of a half. Write the equation. So when we're talking about compressions or expansions, that's the stretches and squishes. I always use the non-math words when I'm describing them, but that's okay. And it's a cosine graph, so it's a cos bx. Compressed vertically, compression vertically, that's talking about this value in front. So it means it's been squished, and the factor is 0.25. So that means a is 0.25, right? It's been, the normal graph would be here, but it's not starting up at 1, it's starting up at 0.25. So the amplitude is 0.25. All right. A little more difficult is to figure out what b is. So it says it's been compressed horizontally by a factor of a half. Well, if we think of this, if it's been compressed, normally the period is 360, right? But the period's 180. So the period is 180 because it's been squished horizontally, where it starts. The normal graph starts repeating every 360. This one's going to start repeating every 180. But we also know the period is given by the little expression 360 divided by b. If we can't see what b is, we can always set up a little proportion here where that we get from the question, the period we get from the question, and that's the period for any function that's got a value of b in there, right? This is the expression formula for the period. And now I can calculate what b is by cross multiplying. And you probably could see, because we did this one earlier, that b is 2, isn't it? And if you can get that without doing this work, you can just read it and understand what b is, then you're welcome just to write down this final answer. But if not, that takes a little bit of work, and it'll take a little bit of practice, which is what you're up against now. Because we're done.